Hi, I'm Raphael Mudge, the Cobalt Strike, and today I'm going to present the Agentless Post-Exploitation lecture I gave at Sans Hackfest today. Now, if you're viewing this online, I want you to know you are probably getting the better half of this bargain. Something funny happened to me today. I show up to the Hackfest event, and the time slots are pretty tight. They're 35 minutes with no real break between speakers. So I show up, I get on stage, and I plug in my laptop, right, via the HDMI, and nothing. So fiddle with it for a minute, try to get things working, no go. So the gentleman handling audio-visual comes up and decides to work on it, all fine. I decide to start the presentation, easy, right? Let them figure it out, it'll get going, we're good. Then my laptop crashes, taking with it my slide deck and the demonstration I painstakingly staged. Yep, that's how my talk began. No worries, I kept going, talking about the material, and probably about a good 10 minutes in or so, things rebooted and we were able to get the slides to display. So that's fine. But needless to say, it was a pretty interesting way to give a presentation. But if you're watching this online, great. I am really happy to have you here. We're going to go through agentless post-exploitation, which is actually one of my favorite hacking topics. And agentless post-exploitation is using the remote administration services and capabilities exposed by Windows to attack targets. So it's using what's built in to meet post-exploitation objectives without the use of malware. And you may be asking, why? Why agentless post-exploitation? Well, agentless techniques for me are at least a safe way to interact with a very hardened, well-defended, well-watched server and pull the results without looking like somebody who's using run-of-the-mill malware. One drawback, though, to these techniques is that they do require that there are accessible services for remote administration of the target you're after. So, and there's not a lot of automation behind these. These techniques are very much you and a command shell working against the target. In this presentation, I'm going to go through the following topics. Agentless post-exploitation does require administrator rights to the target, so we'll talk about that. I'm going to take you through a couple different primitives to execute commands on target. We'll talk about upload and download. I'll also talk about process manipulation, how to recover credential material, and how to repurpose that credential material for use with these techniques. I will also talk about user exploitation, taking screenshots, logging keystrokes, and how to turn a system that you can control into a pivot point for attacking other targets without putting malware on it. Pretty cool, right? And I know there's a lot of topics here, but the intent is to show you that if you have an administrator level trust with a target, you can make the target do the things you need without putting malware on it. That's the main lesson of this lecture. And it's really going to come together, I think, when I'm able to give a demonstration and showing all these pieces working together at once. Okay, so I mentioned it a moment ago, but let's get this up right out of the way, right up front. Agentless post-exploitation is evil system administration. It is attacking a target with the things exposed by Windows to administer the target. Now, naturally, to do system administration of target, that means you need system administrator level rights on the target. So if you have an administrator level trust, meaning your current user or token is a local administrator on the target, or you happen to have the trust material for a domain administrator, you can do things to the target. You can interact with shares that are only meant for administrators. You can schedule processes to run at a certain time. A lot of different things. One of the things I like to do is I like to check if I am an admin for a target. And I typically do that by trying to carry out an admin-only action, such as getting a listing from the $C share or using @ to get a listing of scheduled jobs. Now, let's talk about a few primitives to execute commands. First, I recommend every red teamer pay attention to what I call the old school 4, which is @ shtasks, sc, and wimic. These are ways to blindly schedule or run commands on a target that you have administrator rights for. And the value of this is if you know these commands inside and out, if one or more of them fails, you at least have a chance that one of them is going to work. And in my own experience, I've seen several of these mitigated, but very rarely all of them. So let's start with @. @ is a very old task scheduling service. In fact, it's deprecated now. Windows 8 and later, 2012 Server and later, you can't target them with @ you can't run @ from them. But if you have a target that's older, you can do net time, whack target, to get the time on the target, and use @ to schedule a program to run in the future. Okay? And that could be whatever you want, whatever program, and its command arguments. Shtasks is the successor to @ Shtasks is like @ but with more complicated syntax. Okay, it has more power too, but the syntax, I always need a reference when I use it. But shtasks, you can create a task, schedule it to run in the future, and you can also kick off the task with just shtasks whack run. So this is the syntax to schedule a task to run his system. You can also run commands by creating a service or modifying an existing service. Change it back though. If you use sc, whack target, you can use the service control manager to create a service on a target. You just do bin path equals space, and then the program you want to run and the arguments you want to run it with. One thing I should emphasize though is the service control manager expects that you're running what I call a service executable. And a service executable is a program that has a few functions that the service control manager expects to be able to call and interact with. If it can't, Windows is going to run the program. The service control manager is going to hang for a few seconds, and it is then going to terminate your program saying, hey, it took too long to respond to my queries and requests. So the way to get around that is by running a service executable in the first place. If you can't do that, you can create a service for command.exe, whack C, whatever you want to run, and then if Windows kills a process, what it's going to kill is command.exe, but your thing you kicked off with it will keep running. So nice little trick. Then there's wimic. You can use wimic, specify a target, called process call create, program, and its arguments. So these are 4 different ways to run a program. No big deal so far, pretty standard stuff. Now, one thing about these 4 methods is that they do run the commands blind, meaning you're not going to get output back from them. But these commands are very valuable for lateral movement. They're also valuable to weaken the target or change its configuration to make it favorable for whatever agentless post-exploitation technique you want to use. For example, Deep Panda is an actor followed by CrowdStrike, and what Deep Panda would do is they would, I believe it was use wimic to remotely manipulate the registry on a target to enable RDP and set up the sticky keys backdoor so they could RDP into a target, work with it that way. What are some techniques for executing commands and getting output back non-blind? Well, you can take advantage of PowerShell remoting via WinRM. And WinRM, it's off by default, but some administrators enable it for, go figure, system administration. You'll know it's up if port 5985 is reachable to you on the target. Now, built into Windows is a commandlet, invoke command. And invoke command lets you specify a computer name and a script block. And within that script block, you can put whatever PowerShell expression you want, and Windows will shuffle that off to the target over WinRM, get the results, send them back, and present it to you. So invoke command gives you two-way command control of a target, the ability to tell it what to do, and get results back. It's very nice. Another one that's a personal favorite of mine is invoke WMI command from PowerSploit. An invoke WMI command comes from Matt Graber's 2015 Black Hat presentation. In that presentation, Matt Graber detailed several techniques he had a chance to observe from post-compromise investigations, and invoke WMI command allegedly came from observed Russian advanced threat actor tactics. What invoke WMI command does is uses WMI to kick off PowerShell on the target. Okay, nothing special so far. But what it does is it sticks the results of the PowerShell expression or string you chose to run, it sticks the results into the registry. It then uses the WMI registry service provider to reach into the registry on the target via WMI and pull the results back. So with invoke WMI command, you have two-way command and control of a target, the ability to send tasks and get output over WMI. It's pretty sweet. So invoke WMI command is a personal favorite. Now, what about the ability to upload and download files? Big reveal here. The way I tend to do this is via shares. I abuse $, and admin$ pretty heavily, and I put files on target by using copy, and I pull files back using copy. Nothing special. Now, one thing to note, $, and admin$ are shares that are accessible to the administrator if they're enabled, and they exist to make it easy to push software to many systems at once remotely. Now, sometimes these shares are going to be turned off. You can turn them back on. Just do net share $, or net share admin$ to re-enable these shares. Again, maybe you can see why I emphasize right away the old school for running commands on target. This is a great example of a weakening or softening measure to enable agentless post-exploitation. Is running net share $, and net share admin$. Now, sometimes you'll run into situations where you can query a share, you can list files on a share, you can pull files back, but you can't write files to your admin$ or $, shares, even though you're admin. I know what you're thinking. What's a red teamer to do? Well, I have run into this situation, and I'll be right up honest with you. It's pretty miserable. One thing I had some success with was to write a script that would take a base64 encoded local file and push that file to the target by running echo, part of that string, and appending it to a file over and over and over again to build up my base64 encoded local file on the target. And then using one of my old school for to run certutil to turn that base64 encoded file back into the original binary. So I have done this. I've also done things like staging files on sysvol, since systems in the domain need to be able to access that. But this is one technique to upload a file if for some reason you can't write to those shares. The certutil exe trick came from my friend Matt Graber. I saw a tweet he put out, I think it was last year, mentioning it, and he has a nice GitHub gist where he documents this technique as well. So this is one way you can reconstitute a file on a target if you can't write a file to a share. What about process manipulation? The ability to list processes running on target and to kill them. Well, fortunately, the Windows task list and task kill commands both have options that let you specify a target. It's as easy as that. One thing I'd like to emphasize here is that many Windows commands to administer your current system, including commands to manipulate the registry, have options that let you do these things to a remote target. And using those things is what agentless post-exploitation is all about. But I'd like to point something else out. Even though there's the normal system administrator way to do things, there are often other ways to do the same thing as well. For example, you can list processes on a remote system using WMIC. If you use WMIC process list full, you will get more information than you ever thought you wanted to know about every process that's running on the target. If you want something that looks like what you would get from task list, you can do process list brief. If you want to kill a process, you can do that via WMIC as well. Just do WMIC, whack node, the target, where process ID equals the process ID number, call terminate. That will let you remotely kill a process. WMIC is very, very fertile ground for querying a system and carrying out actions on it. And so I highly encourage digging into that as much as possible. Now, let's talk about recovering credentialed material. One of my favorite commandlets is invoke mimikatz, which is part of PowerSploit. And invoke mimikatz has a computer name flag that lets you specify a target. And what will happen when you use this is invoke mimikatz will push the necessary commandlets and the encoded DLLs over to the target via WinRM. It will execute mimikatz on the target by loading the DLL via PowerShell and present the results back to you, all sent via WinRM. So this is a way to run mimikatz on a remote target without putting an agent on that system, okay? You can also use invoke mimikatz computer name, target, and a command, and run an arbitrary mimikatz command. And this is very powerful because mimikatz contains a number of tools to harvest credential material and to weaken the target and install various, I think of them as configuration backdoors. So there's a lot of amazing capability in mimikatz, and this lets you use that capability on a remote target in an agentless way. Here's another favorite one. It's DC Sync. DC Sync uses APIs in Windows designed for domain controllers to replicate information between each other. And what DC Sync lets you do is target a domain controller and pull back hashes for specific users. Red team operators often use DC Sync to pull back a curb TGT hash so they can forge a golden ticket later. So this is a very, very nice way to pull credential material, in this case a hash, from a domain controller without installing malware on the target or doing something dangerous that requires, say, injecting into LSASS. It's pretty cool. Now, I want to detour briefly off of the agentless stuff and talk about how to take credential material you may have recovered and make use of it. And to do that, we're going to need to talk about access tokens. In Windows, your identity on a system is contained within an access token. And every process that's running on a system has an access token associated with it. More so, it's possible that an individual thread in a process might have its own access token that's different from the process's access token. What's important to know is this token is your identity on the current system. This token also references what is called a logon session. And that logon session is the credential material Windows will use to authenticate you to a remote system. This is a big deal because your identity on the current system does not need to match the identity in the logon session for your current token. They can be completely different things. And you may be wondering, why? Well, let me explain that. First, if I use the run as command in Windows, run as will let me specify a domain, a user, and a command to run. And when that command runs, Windows will create a token for that user. And it will go through all the steps needed to authenticate that user. If it's a domain user, it will check with the domain controller, make sure your creds are correct. issue you a token, and give you a process running with that user's identity. So if you go to that process, type who am I, here you can see my PowerShell instance is glitter/administrator. Makes sense? Sure. All we did was create a process as another user. Now, riddle me this, Batman. Let's say I want to access a resource on a system that is joined to a domain that I'm not part of, but I happen to have credentials for a domain user on that domain. Or let's say I happen to have credentials for a local user on a remote target, and I want to use those credentials to access a resource exposed by that target. What am I to do? Well, Windows does allow for this, and that's where you see stuff like this. Run as whack-net only will create a copy of your current access token that has a logon session that references the domain, the username, and the password you provide without checking them at all. So with run as net only, you can spin up a process, but that process is indistinguishable on the current system from any other process running as you. You are you on the current system. But when you interact with a remote system, Windows will use what is in that logon session, and what is in that logon session is the information you provided with no other verification. Windows will use that information to authenticate you. Here you can see I kicked off PowerShell.exe with whack-net only using the glitter administrator user. And in my PowerShell window, I type who am I, and it says I am what a hog, okay, the current user. But if I do invoke command, remember, winrm, to the DC on this network, that's -computer name, -script block who am I get back the result administrator, because that is the information in the current access token for PowerShell exe in that program's logon session. Cool, right? This is a big deal because for agentless post-exploitation, our ability to create an access token for arbitrary credentials is our ability to assume whatever identity we happen to have credentials for and use all of these techniques with that identity. That's why this is important. So if I have credentials, I can do run as whack-net only, the domain, the user, and the program, specify my password. I'm ready to rock and roll. Now let's say I happen to have a password hash. Can I use that to assume an identity as well? Yes. Yes, I can. Mimikatz has in its Sacrosa module a PTH command for pass the hash, go figure. And this lets you specify user, domain, a password hash, and a program. And what it will do is create an access token with a logon session that is populated with just the information you provided. So when you try to interact with a remote resource, Windows will pass the hash for you. Pretty cool, right? I think so. One thing to note is depending on your offensive platform, it's very likely that your offensive platform has built-in versions of these capabilities. In Cobalt Strike's Beacon, make token is run as net only, and PTH is Sacrosa : PTH. So I recommend consulting the documentation for your favorite offensive tool set to learn more about how to do that there. Okay, now that we're past that detour, let's get back to the agentless post-exploitation techniques. You may be asking, how do I wait for this ambulance to go by me? You can see I'm being recorded, so I can't just edit it out. Bye-bye, ambulance. All right, we're good. So let's talk about user exploitation. How do you gather screenshots and log keystrokes without having to get a full malware kit on a target? Well, one way to gather screenshots is to use a built-in tool called Problem Step Recorder. I haven't used this in the field yet, haven't had an opportunity yet. I just found out about this this year at the blog post referenced in this slide. But Problem Step Recorder What it is, it's a tool built into Windows to record screenshots and actions taken by a user while it's running. And very conveniently, Problem Step Recorder has an option to disable its GUI. That's what the whack GUI 0 flag does. While this tool is running, it will gather information for the current desktop session until you run psr.exe whack stop. When you do that, the Problem Step Recorder will stop and it will output all the user's activity to a zip file that you, the attacker, can conveniently grab. Now you may be asking, you may be saying, okay, Raf, that's great. Big if, I can get Problem Step Recorder to execute within the user's desktop context. On a modern system doesn't let me do that. SC isn't going to let me do that either. Wimic, I don't know how to do that. How do I do this? What are my options to run Problem Step Recorder within the user's desktop session? That's a good question. There is a way. You can use tasks to run a program interactively within a user's desktop session if and only if that user is currently logged on. There is one caveat, one sting, if you will, and that is you have to know the user's password to do this. But if you have the user's password, you can do this pretty easily. If somebody knows a way to do this without a password, I'd love to see it. I just know that in my own testing, if you don't specify a password here, kicking off the task will silently fail. But tasks, whack IT for interactive, is a way to do this, and we'll demo that in a moment. What about logging keystrokes? This is one I have actually done. Managed to actually log keystrokes on a target where running malware or malware wasn't going to survive for very long. And the red team I worked with, we did this via DLL hijacking. We took source code for a keystroke logger found on the internet. Very simple keystroke logger, just output keystrokes to a text file. And we copied this keystroke logger to $, which is the C drive, Windows link info DLL. And that is a known location for potential DLL hijacking against Explorer.exe. Now to make Explorer.exe on the target load our DLL, we used a remote task kill to kill it. And when you kill Explorer.exe, it will automatically restart. Now for this DLL to actually load and start working, the user does have to click the start button. But once they do that, you should be good to go. And from that point on, we were able to actually periodically pull keystrokes by just copying this log file off the $C share on the target. As easy as that. Now this is putting an artifact on disk, but putting a file on disk is much different than having to have a full malware kit with command and control and everything else as well. So it's a lower barrier. So that is one method of capturing keystrokes without putting a full agent on target. What about pivoting? How do you take a system that may be able to reach an asset or resource you want to get to, but you don't feel comfortable putting malware on it? How do you turn that system into a pivot point? Well, Windows happens to have the ability to create a port forward. And you can do that via the netsh command. So if you do netsh interface port proxy add, you can specify the local port to bind on, the port to bind on your pivot point, and any connections that come to that port, you can specify which host and port the connection should be forwarded to. A couple of things. This does require that an IPv6 stack is installed on the target, and these port forward proxies do persist between reboots, so you do need to clean this up. I have a pretty blunt command there to do that. netsh interface port proxy reset. We'll clean that up. I recommend being a little bit more targeted and using the full syntax to delete the configuration you added so you don't erase the user's configuration. Whatever you want to do, make sure you do clean this up. So this is a technique to do pivoting. And if you combine this with one of our various techniques to execute a command on a target without an agent, you can set this up without putting malware on the target. Pretty cool. Okay, so I've taken you through a survey of different types of agentless post-exploitation techniques. And I hope you've gotten a sense that this is just scratching the surface, just helping you realize some ways you can accomplish your post-exploitation objectives. What I'd like to do now is a demonstration where I work from a foothold in a network. In this case, it's my test lab, Acme. And we're going to go through an attack chain to steal the source code to Acme's secret weapon, working only from a foothold. So we have malware on a target inside of Acme calling out, but that's it. We're not going to put malware anywhere else. We're going to do everything else agentless. Okay, let's go ahead and do it. So here I am in Kali Linux, and I happen to have Cobalt Strike's beacon payload running on a workstation in this target network. Okay. Now, first things first, we're going to go ahead and just query the domain computers group on the domain controller to get a list of computer accounts for systems joined to the domain. And this is kind of a very quick reconnaissance thing. Now, what I want to do is check if I am currently a local admin on any of these systems. So let's query Josh Dev, $, and we get back access is denied. I am not a local admin as far as that system is concerned. That means I cannot do things to it using these agentless techniques. Boo. Let's try another one. Let's try file server. We're going to just do a directory listing on $, and there we go. We get back a listing of the C drive on $, or on the file server. Pretty cool. So we have an administrator relationship or administrator rights on that system. We can do things to it. First thing I want to do is run Mimikatz. So what I'm going to do is, let's see here. We're going to import a script from PowerSploit. Make sure I use the latest version. We're going to import invoke Mimikatz into this beacon. And I'm going to just do invoke Mimikatz -computer name, and the target is file server. And even though I'm using Cobalt Strike's beacon here, I'm trying to keep this very generic, upload, download, execute, and PowerShell, so you can take these concepts and apply them to other offensive tool sets as well. So we're doing invoke Mimikatz, computer name file server. Remember, this is doing all of this over WinRM, port 5985. And here's our results, okay? And you can see we don't happen to have the plain text credentials, boo, but we do have the NTLM hash for the administrator user on the domain corp. So that will work for our purposes. What I'm going to do next is I'm going to turn that hash into an access token. So we're going to use the alias baked into Cobalt Strike, pass the hash, corp administrator, provide the NTLM hash, and just give that a moment. And what you'll see is that this is run Secursa PTH via Mimikatz. And Cobalt Strike does is takes the program that Mimikatz runs and steals the token from it, so that all the actions we carry out going forward have that access token. So now we are the domain admin user on this network. Let's go ahead and test that out. Let's try to query $C on Josh Dev. And you'll see it's a different story this time. We now get back a listing of the C drive. Pretty cool. Cool. All right. Well, Now, what I want to do next is I want to find out what is happening on Josh Dev. I want to take some screenshots and have some situational awareness of what the user is up to. So first thing we're going to do a task list using WAC-S and specifying Josh Dev to get a listing of tasks on that system. So I'll let that run. And here we go. Here's the output task list. No real difference between running this locally or remotely, except these are the results for that remote system, Josh Dev. And you'll notice that there is a user. I'm just going to shrink this so you can see what it looks like pretty printed a little bit. You'll notice that there is a user logged into desktop session 1. Okay, so domain user Josh. Cool. So what we're going to do is we're going to take and run problem step recorder in that desktop session as the user Josh Sokol. And we're going to use shtasks to do that. So this is going to be a hairball of a one-liner. But let's go ahead and get started on it. Let's do shtasks, create, task name, we'll call it spy, task run. We'll do C Windows, System32, PSR.exe, whack start, telling it to start, whack GUI 0, telling it to disable the GUI, whack output, and where we're going to store the results, we should put this somewhere that Josh can write to. And we're going to have this run once. We're going to put in just a fake start time. We're going to run this on Josh Dev, and we're going to run this as the user, Josh Sokol. And one thing I'm going to white card for this demonstration is me knowing the user's password. So I'm going to put that in here. It's devrox1234. Finally, we can do the whack IT flag for interactive, making the scheduled task run if Josh is logged in within his current desktop session. Pretty cool. Now let's go ahead and do shtasks. We'll use the run verb to run the task spy on the remote system Josh Dev. Just like that. And there we go. In theory, the problem step recorder is now running on Josh Dev. We don't have to rely on it in theory, though. We can just do a task list and pipe that to a find string for problem step recorder.exe and wait a moment for the results. Now is a good time, if you have children, to tell them that you love them very much, that you care about them. And there we go. We now have our results. We can see that the problem step recorder is indeed running on that system. Cool. Now what I'm going to do, just in the interest of making an interesting demo, is I'm going to do things as a user on the Josh Dev system. Okay. And that is, again, just to pick our interest when we go through the data. Now, let's let some time pass. Time has passed. And let's go ahead and stop the problem step recorder. So it will write out the results to a file, and we can collect them. So I'm going to, same thing we did before, I'm going to use shtasks to run problem step recorder. So we're going to create a task called spy stop. And we'll do psr.exe, whack stop. Same parameters as before. And again, we have to provide the username, the password, and whack IT to run it in the context of the user's desktop session. And with that task created, we can do shtasks, whack run, task name spy stop. And we're going to run that on Josh Dev. And there we go. So now, in theory, there should be a beautiful, beautiful out.zip file and C users Josh Sokol on that target. Let's find out. And there it is, out.zip. Cool. Now let's go ahead and download that file. Now we can do that pretty easily. We can just use the download command in Cobalt Strike and reference the full path to the file we want to download, so the UNC path. So we're going to do Josh dev $, users, Josh Sokol, out.zip. And there we go. We've now downloaded the out.zip file. Now let's come over to Cobalt Strike, go to View Downloads. We're going to hit Sync Files. And we are going to, oops, did that a little bit prematurely there. I actually want to drop that to a folder called Demo under Dropbox. There we go. And now we're going to go to a Windows system that has access to that demo folder. Unzip out.zip and open up the recording generated by Problem Step Recorder. And here you can see what's happening on Josh Dev. We can see the user double-clicked putty. And there's what the user sees. And we can see what they're double-clicking. So you can see the user's getting ready to log in. And so this gives you a pretty good idea of what the user was up to. We can see the user is logged in as the user J Sokol. And so we have a sense of all the different things the user is up to. So that's the output of Problem Step Recorder. I think it's pretty neat. Pretty good for not having a piece of malware on the target. So cool. Now, let's say we want to get onto that Unix target. Let's say we hypothesize that that Unix target happens to have the source code we're after. Now, let's also say that I was logging keystrokes using the link info DLL technique. Now, there's only so much I want to do to set up a demo. So let's say I was doing that. So let's say we have the credentials and we now want to go after the Unix target we saw our user, our developer interacting with. Okay? Let's demonstrate how to do that using the agentless post-exploitation techniques. What I'm going to do next is I'm going to import another PowerShell script from PowerSploit. What I'm going to import, is code execution invoke wmi command.ps1. Remember, this is the script that gives us invoke wmi command, which gives us the ability to do to run commands and get output over wmi. Let me add my select statement here to the pipeline. So we're going to run on Josh Dev over wmi is just a simple net stat. I want to see where Josh is connected to. So we're using invoke wmi command to kick that off. And hopefully soon we'll get some results back. Here we go. So here's the output of netstat running on Josh Dev, given back to us via wmi. And we can see that Josh is connected to 192.168.57.18 on port 22. That is probably our Unix target. So let's go ahead and just quickly try to ping that target. I want to prove to you that my current foothold cannot touch that system. Okay? So we do that, we see nothing. So let's hit the up arrow. We're going to use invoke wmi command to run ipconfig on Josh Dev. And what we're going to get back is some output for ipconfig. And you can see that this is a dual home system. So it has that access to that 192.168.57 network, and it has the IP address 10.10.10.18 as well. Now, what we want to do is turn Josh Dev into a pivot point so that when we hit Josh Dev on a certain port, that connection gets bounced to the system we otherwise can't access, that Unix target. And we're going to do that. We're going to turn this into a pivot point by using invoke wmi command to run netsh. Okay, so what we'll do is PowerShell, invoke WMI command, computer name, Josh Dev, payload, NetSH interface, port proxy, add v4 to v4, listen port 2222, meaning Josh Dev will listen on port 2222. That's 10.10.10.18. And when a connection comes in, Josh Dev will make a connection to 192.168.57.18. That's our Unix target on port 22. Okay. So let's go ahead and task that up. And now we're in a good position to go ahead and try to reach that Unix target. So I'm going to use the socks command in beacon to create a socks pivot on my controller. And anything that goes through that socks proxy is going to ride through my C2 to the foothold agent, through the foothold agent to whatever we specify as target. And we're going to try to use that to reach the port forward we created on Windows. So let's go and open up proxychains.conf and let's configure proxy chains to use my controller, port 9910. We're going to do proxy chains. We're going to SSH as the user JSOCL to 10.10.10.18 because we're hitting Josh Dev on port 2222. Why are we doing this? Because we're trying to hit that port forward, and then Josh Dev will take us the rest of the way to that Unix target that we're trying to reach. So let's go ahead and do this. You can see we're being prompted for the password. If we had been logging keystrokes, we would know that the password is Josh Rocks. And here we go. We are now interacting with that Unix target coming from 192.168.57.8, which is the second interface of Josh Dev. So that's an example of using agentless post-exploitation techniques for pivoting as well. Now, you may be experiencing a what did he just do kind of moment. So if this was a little bit difficult to follow because just a lot of commands being run, let me show you visually what happened. We have a foothold on a workstation. That foothold is calling back to our controller on the internet. And we use that foothold to run the invoke Mimikatz commandlet and to run it on the file server over WinRM. And that yielded credential material that we were able to use to take on the role of a domain administrator user. Now that we had domain admin rights, we had what we needed in terms of credential material to use agentless post-exploitation techniques against Josh Dev. So we used those techniques to conduct user exploitation activities, for example, gathering screenshots, learning where Josh was connected, and figuring out what he was up to. And through that, we were able to identify a target, a Unix system that we wanted to reach, pivoting through Josh Dev. So we used our agentless techniques to create a port forward on the system, and we pushed an SSH connection through our malware and its controller to Josh Dev on port 2222, and our port forward we created on Josh Dev took us the rest of the way by initiating a connection to port 22 on our desired Unix target on our behalf and relaying that traffic between the two connections. So that's what we just did. Now I know we went through a lot of material here, but what I hope you'll see is that in the demonstration, I showed you some element of everything here, okay? So we talked about different ways to execute commands without having an agent on target. We talked about how to upload and download files using shares. I took you through a few process manipulation techniques. We talked about how to recover credential material and how to actually use that credential material to enable your agentless post-exploitation activities. I also took you through a couple techniques for user exploitation, and we talked about pivoting, and I demonstrated all of these things as well. The main point here is that the more you understand what you can do with Windows beyond what is exposed by your offensive platform, the more capable you're going to be as a red teamer. I also find that sticking with system administration tools and techniques is a great way to blend in with other activity in a target environment. And if the goal is to train a blue team and help them up their game, these are a great set of techniques to offer them a very interesting analytical challenge. So that's my presentation. I hope you enjoyed it. Good luck and happy hacking.